Good morning, everybody. Welcome to KAUST. My name is Sarathy. It's nice to have you all here for the first KAUST Combustion Institute Summer School. I would like to introduce the director of the Clean Combustion Research Center, Professor William Roberts. He was the first associate director for the center, and he's been now for over 3 years the director of the Clean Combustion Research Center. So he's going to give you some words about KAUST and also welcome you to the school.
Assalamu alaikum, sabah al khair. So how many of you, this is the first time you've been to Saudi Arabia? Okay, good. And how many of you, this is the first time you've been to KAUST? Okay, good, the vast majority of you. Well, welcome to KAUST. So I'd like to give just a little bit of history about the university. So in 2006, King Abdullah sat over where the monument is. Hopefully you'll get a chance to see that, cast his vision southward and said, I want to build a new Islamic house of wisdom that will be a beacon for international education and societal changes. So he tasked Saudi Aramco to build the university, the oil company, and build it in 1,000 days in 2006, and insisted that classes start September of 2009. So this was all marsh. We were part of Thule, the historic fishing village to the south of us. So Aramco, the largest employer in the kingdom and probably related to most of the things that function very well in the kingdom because of the management structure, designed it and built it in 1,000 days, and they had 56,000 workers here at one time. So 10 times the population that we have right now. So Thule exploded to support all these workers. So they built it, they made the deadline, and the agreement was that Saudi Aramco would operate the university as a subsidiary of Aramco for 5 years while our endowment grew. So KAUST was built, we were hiring faculty, we were recruiting students, and then in 1st of July 2014, we became an independent university. So we're a private university solely funded by our endowment. So we have about 150 faculty spread over 3 divisions, physical sciences and engineering, which is where we sit, mathematical sciences and engineering, biological sciences and engineering. And then we have programs, typically mechanical engineering, chemical engineering, chemical sciences, etc. So all faculty belong to one of these programs, and there's 13 programs. And then faculty can also choose to belong to a center. So centers are designed to do more of the industrially based research, so outcome-driven research as opposed to inquiry-based or fundamental work. So about half the faculty, half the students, half the postdocs belong to a center, and there are 10 centers. And these centers are roughly organized around the 4 research themes of KAUST. And if you look at our symbol, there's the 4 little dots, right? There's a yellow, a green, a blue, and an orange. And those signify food, energy, water, and the environment. So those are the 4 issues that affect the kingdom, the region, and the planet. And those are all really challenging problems. And you really need to be multidisciplinary to approach those. And so you see the concentric lines that connect the 4 globs together. Well, that's a Fresnel lens, so we're supposed to bring it all into focus. I don't know how much we paid for that symbol, but that's what it means. Somebody watching the time? Okay. So we have 150 faculty, 10 centers. Clean Combustion is one of the centers. So we play in both the energy and the environment sector. We have 9 faculty, about 85 graduate students, the vast majority of which are PhD, and about 30 postdocs and 15 research scientists. If you look at our demographics, we have across the university, we have just under 1,000 graduate students, and about 80% of those are PhD students. So quite different than what you would see in North America or Europe, where the ratio of masters to PhD is inverted. We have 101 nationalities on campus. So our president used to say that we're the most international school in the world. I think we still are. About 35% of our students are Saudi. The rest, typically, as you would see in engineering and science, Asia, China, some Europeans and some North Americans. So we have about 100, almost 1,000 graduate students. We have about 350 postdocs and about 300 research scientists. So and no undergraduates. And so our makeup looks a lot more like a national lab than a typical undergraduate university or even graduate level university. So we're very heavily focused on research. You'll see in the lab tours that start at 10, we really have very nice facilities here. We have very good faculty, and we're able to recruit very good students. The university is expensive because we have to provide the whole town, right? So we all are required to live within the gates that you pass through to get here. So we have a fire department, we have a clinic, we have restaurants, we have schools for the children. In fact, we have more children than we anticipated. Turns out this is a very conducive environment for children, so we have 1,492 K through 12 children on campus, much more than we were expected. So we're continually building new schools for the burgeoning K through 12 population. 2 minutes? Okay. There's a lot of construction still going on. As you came in yesterday, if you looked on the left, we're building several hundred new homes. There's building a new hotel. We're renovating the student center, the student houses. We have 2 new industrial buildings. A lot of campus is empty still. We're 40 square kilometers. We only occupy a fraction of that. So we have a research park. Right now, Aramco and Dow are building their buildings, and that's the construction you see if you look out into the bay to the south. They just announced another building, an innovation building that will be starting. It might be a secret, so don't tell anybody, but I think Amazon is building a data management center here. Is that public? I don't know. Don't spread it around. It is now. It's on YouTube? Oh, then it's public.
No, this is live on YouTube.
Oh. You probably should have said that before I said something. I'm just kidding about the Amazon thing. Just kidding. Any questions? Well, we put a great program together for you, Manny and Professor Dibble. I think it's informative. The guest lecturers that we brought are quite engaging, so please engage them. Ask them questions. They've come a long way. So maximize their travel. That's it. Okay, so I'm going to introduce Professor Dibble. So Bob Dibble's well known in the combustion community, grew up in the Las Vegas area, went to Berkeley, then went to Wisconsin for his PhD in chemical engineering, went back to the Bay Area and worked at Sandia National Labs. The combustion research facility is kind of a model that the CCRC was built on. So he spent many years there doing a lot in the growing, emerging area of laser-based diagnostic techniques. Then went to Berkeley as a faculty. And then we were able to bring him here 2.5 years ago-ish.
3.2.
3.2 years ago, just over pi. Okay, so with that, I'll turn it over to Bob. And thank you, enjoy the week. Again, we have volunteers in the blue shirts. We have 9 faculty. Please stop us and ask questions. And we're very happy you're here. Thank you.
Thanks. Thank you, Bill. You're a hard act to follow. While I was at Berkeley, it turns out my roommate from college joined Aramco from UC Berkeley. So he worked at the Ras Tanura oil refinery in the late 70s. So I knew plenty about Aramco. Aramco came by the Berkeley campus 10 years ago, a little bit more, to recruit some help. And I rapidly raised my hand and said I'd like to be part of this, and it's been a wonderful ride since. Bill gave you a review of this campus and how we sort of got to where we are right now. I gave a pop-up talk, I think, last week, and then Manny appointed me to basically give the same talk again, more or less, okay? And what that talk was about is one of the champions from Saudi Arabia and Aramco working on carbon capture sequestration we had invited to give us a talk here at KAUST. And I was the lucky person to introduce him, and I wanted to say that we all live in interesting times, and I want you all to look at this week that you're spending here at KAUST in this combustion class to augment those interesting times and to reflect upon them, sort of as follows. I said, I'm a lucky guy. I grew up in Las Vegas, Nevada, and that's actually, I always chuckled and said it's a suburb of Los Angeles, California. So I was in Los Angeles numerous times with high school sports and high school music groups. And in 1965, the air quality of Los Angeles was, visibility was very poor. You couldn't see much. And it was only in the late 1969 that the United States started to put air quality regulations on automobiles and power plants. So you think of air quality and air regulations as sort of probably a standard thing in your life. I can tell you it's relatively new, okay? So I can tell you that the air quality has greatly improved in Los Angeles, even though the population of the valley has increased by a factor of 3. And so but that was due to a lot of effort, regulatory agencies, democratic process, all kinds of things that involved combustion engineering at various levels. And so my encouragement to the group will be kind of repeated several times is you need to just keep watching all of these various interesting factors that are part of combustion. Certainly air quality is a consequence of combustion. So the biggest air quality problem in my career has been nitric oxide. And by the time we got into the 1990s, nitric oxide had largely been solved. I know that'd be a controversial statement to some, but we used to have automobiles that would spew out 1,000 ppm of nitrogen oxides, and nowadays they're something more like three. So that's 3 orders of magnitude, a lot lower. And nonetheless, the effort continues to keep reducing that number. But what's loomed up in the interim time is another pollutant is now CO2. And we did not imagine, I might say that I was a graduate from the University of Wisconsin in chemical engineering. And I had started my career using lasers to make chemicals. So you're in chemical engineering, you make chemicals, and I wanted to, I'll use my arm as sort of some kind of molecular bond, and I wanted to put a laser photon into a joint and activate that so that I could get some other chemicals to react with it, and I'd make a new chemical that would be profitable, of course. And as it turns out, if you do something like that, that energy that you deposited rapidly distributes to the molecule so quickly that you just basically heated the molecule rather than specifically anointed one bond. So it basically didn't work. But having spent a graduate program in lasers, I was readily adapted to doing laser diagnostics in combustion. And as Bill points out, I was one of the first founders of the Combustion Research Facility in California. I wanted to back up a little bit and just remind everybody that I did grow up in Las Vegas in southern Nevada, where there's very little water. And people ask me even today, what's it like to live in Saudi Arabia? And I says, just like where I grew up, okay? And there's no water, and it's gravel and so on. Well, anyway, I want to say that I worked at the Combustion Research Facility, and we worked on fundamental things. Always, the usual list back then was nitric oxide. It was also soot. And you'll see that throughout your conference this week, we're still looking at those similar topics. And it didn't go away. We just have to stay on top of that all the time. But in the background, you'll see that CO2 is yet an issue. And let's see if I made some notes. Yeah. One of my students who's here, Ishan Singh, I hope you meet him. He's talking, and he reminds me that one of the defining papers of this century came out in 2003. The second author was Dan Kamen, a friend of mine at UC Berkeley, and that paper won the Nobel Prize for the Nobel Peace Prize. And so he calls this century, the century that you're in, the CO2 century. And I think it's fair to say the century that I was part of was the nitric oxide century, or certainly the last half of that century. So much of what we do in combustion is focused on minimizing the emissions of CO2. And even to the point of, it's controversial, and that means we're in exciting times. When I talk, for example, of carbon capture and sequestration, there are members of the community and members of my former faculty at Berkeley that say carbon should be left in the ground and we should not burn it whatsoever. We must do something else. And so that's plenty discussed. At the same time, there's others who say why the air quality and CO2 is an issue. We're going to continue to burn the carbon, but we're simply going to have to capture the CO2 and to bury it. And again, this is not, widely accepted around the world. So you are in interesting times, and you will be part of this process of deciding, well, what direction are we going to go? I can say, in particular, Saudi Arabia and the United States are unique in that they have agreed to work extra hard on carbon capture sequestration. Of the Paris Accord agreements, the two of the nations that work on CCS is Saudi Arabia and the United States. So that's kind of interesting. I have also been working a lot with the United Kingdom on carbon capture sequestration. They're very advanced on it, and unlike, say, Germany, which says we're going to leave carbon in the ground, UK is, I think, is farther along than most people on demonstrating various places where they're going to bury CO2. So one other comment is I'd like you to think about this. That is, I have a book out there, and it's Combustion by Varnotz, Moss, and Dibble. And Varnotz told me when I became the third author of this book that he said, when you go to a meeting, you will look at papers slightly different. You'll ask yourself, do they belong in the book? Is what's being presented an important thing to put into the book? And he's right. I always look at a talk of how valuable is that, and is that something to put in the book? And then I'm reminded that many people use my book for the curious reason that they say it's a thin book. And I bothered to look, and it says, yes, most of my competitor combustion books are big, fat books. And the one that I have is pretty thin. So on one hand, I see stuff all the time that I want to put into the book, but then I have to be careful and have to ask, what am I going to remove from the book? Because I'll try to keep it thin. And by the way, keeping it thin, I'm told by professors around the world that students pick it up and read it, although nobody picks up my book anymore. They just find it somehow on the internet and read that, okay? Let's see. I conclude that I want you to take notes, of course, this week as you take the class, but also just ask yourself, what am I getting out of this? And that is, what was a special part of that lecture? And in effect, keep a diary of this week. I think it'll be valuable, and you'll be proud to reflect upon that in the years to come. One last concept. The way we have this course structured is sort of the normal university way of looking at things, and that is, you'll see that we started out some very basic stuff today, and more basic stuff tomorrow. Finally, we're going to introduce some engine concepts in the next day, and then later after that some gas turbine concepts. I want you to think of just the opposite of the actual way we discovered, for example, thermodynamics was we started with a steam engine. And with a steam engine, one finally figured out that there's something more subtle called thermodynamics. Yet the university always liked to present it in the reverse way. That is, that we start out with basic theory and then we create machines. And I just want you to reflect on the fact that, in fact, it's from the machines that came the theory. Any questions on that? Surely there's got to be something. Well, okay, we have some housekeeping things here. Manny, we're going to break up into groups. I'm going to lead a group. And how many groups do you think we have? 4, 5?
We'll go over it.
Okay, we'll go over it, okay.
Okay, thank you, Professor Dibble.
Okay.
Professor Dibble, you played American football when you were younger? Let's do a demonstration. How do we ask questions here?
Football.
You got a question, Professor Dibble? Go long.
What's the meaning of life?
It's for you to determine on your own. So this is the microphone, everybody. So you don't have to be shy. You're sitting all the way down there. There's a microphone. You play Saudi football or English football or American football or rugby, we'll get the microphone to you, okay? Okay, so we'll just go over our agenda for the week and some of the key points. So yeah, again, welcome everybody to the Clean Combustion Summer School. This is a summer school that's funded by the Combustion Institute. And many of you are familiar with the Combustion Institute. For those of you that are not, it's an international organization situated in Pittsburgh, USA. And every year they support some of these types of summer schools in different parts of the world. And they've had them in US, in China, in Europe, Northern Europe. And this is the first Combustion Institute sponsored school here in the Middle East region and the North Africa region. So we're very proud of this, and we're glad that you all are part of this first Combustion Institute summer school. So we would, of course, like to acknowledge the support from the Combustion Institute, the support of President Jim Driscoll, Professor Kobayashi, who is the chair of this Combustion Institute Summer School Review Committee, for providing their support to the school, and of course the Executive Committee of the Combustion Institute. We're also very thankful for King Abdullah University of Science and Technology, also for sponsoring the school. We have support from the university management, from the Clean Combustion Center, as well as Innovation and Economic Development. And of course, many people have been involved in organizing this school for you. It's not a show that just a few people have put on, so many of you are familiar with Leah and Rahina, who helped arrange all of the travel for you all, so thanks to them. And many students and postdocs were also involved in organizing all the activities over the 1 week. So, please acknowledge their contributions, and you can thank them in person as we go over the week. Also, of course, a key part of this Combustion Institute Summer School is that we have very distinguished faculty coming to teach you the courses. And a key part of getting this type of school up and running is to make sure that you are all exposed to the leading thinkers and the leading concepts available internationally in the field of combustion. And we worked really hard to find the best people to come here to KAUST to present to you their thoughts and their experience in combustion. So in the area of flame fundamentals, we have Professor Kaoru Morita, who's the professor and deputy director for Innovative Energy Research Center in Tohoku University from Japan. He'll be giving you lectures this afternoon, but he's going to be here the whole week. So don't think that just he gives you the lecture and then his job is done. He's here to engage with you the whole week, to interact with you, and please feel free to ask him any questions that you have. From KAUST, we have Professor Hong Im, Professor of Mechanical Engineering here in the Clean Combustion Research Center. He'll be talking more about flame theory and numerical simulations of relevance to flames, which will happen tomorrow. In the field of engines, we have two of the foremost experts in this field. Professor Bengt Johansen is a world-leading expert in internal combustion engines for automobile applications and marine applications. He's a professor of mechanical engineering here at the Clean Combustion Research Center. And we have a leader from industry, Dr. Anthony Dean, coming from General Electric Global Research. He's a technology discipline leader for combustion in the US, and also the Chief Operating Officer for GE's global research activities. And he'll be arriving later today, and he'll be presenting to you very nice lectures about gas turbine engines, and also we'll have a nice gas turbine design workshop for you all. And you'll actually get to see how the thought process of designing a gas turbine proceeds, and how you can apply the fundamentals we learned from flames to actually designing a real combustor. And finally, the last couple of days will be in the area of fuels. And Professor Amr Farouk is Associate Professor of Mechanical Engineering here in the Clean Combustion Research Center. He'll be talking to you a lot about experimental kinetics and studies of fuels to characterize fuels to make sure that they burn in engines appropriately, and also a leading expert in the field of kinetics, fuels, as well as particulate matter emissions. Professor Angela Violi from the University of Michigan, a professor of mechanical engineering, will be presenting to you lectures about kinetic theory, combustion modeling from a fuel chemistry perspective, as well as important emissions aspects. In addition to these distinguished faculty presenting to you lectures, there's going to be some lab demos in the afternoons on Monday and Wednesday. And those lab demos will allow you to actually see where theories and experiments you have learned about in the classroom here are actually being applied in the laboratory setting to make new types of discoveries. In addition to that, on Thursday morning, we'll have a career networking session, and that's when all of you will be participating. I encourage you now to think about preparing your resumes, preparing your introductions, so that when we have this networking opportunity, you're able to present yourself in the best light. And we'll talk more about this as we go later in the week. And of course, no school is complete without the distinguished students, for which all of you are making an important contribution towards. So we have selected you. Not everybody who applied was admitted, okay? So we have selected you as distinguished participants and scholars in the field of combustion and energy to come and join us. We want you to be part of the school. We want you to contribute your thoughts, your expertise, your questions to the vibrancy of this environment. We have 20 international students coming from North America, Europe, Asia, India, China, as well as parts of Africa. So really representing combustion research across the entire globe, which is what the Combustion Institute stands for. It's to really help encourage global interaction in the field of combustion. We have 18 students coming from within Saudi Arabia universities, as well as 32 in-kingdom industry participants. We have also 8 in-kingdom professors, and you can see the universities they're coming from represent universities all across the kingdom. Taif University, King Abdulaziz University, Yambu Industrial College, King Fahd University of Petroleum and Minerals, and King Faisal University. And the biggest companies here in the kingdom, Saudi Aramco, SABIC, and Saudi Electric Company. So we're very happy to have them all part of this school. We welcome you all, and we hope you'll, again, contribute all your energy, your human energy, to making sure combustion energy is really advanced in this next week. In closing, I'd like to say that this university was founded by King Abdullah, the previous former king of Saudi Arabia, and he founded this university to create a new house of wisdom. We called it the Beit al-Hikmah, which was in the history of Islamic science and technology, a time in the history when Islamic scholars really contributed to the global knowledge development in various fields of science. And now the purpose of KAUST, in the words of King Abdullah, were to create this new Beit al-Hikmah, house of wisdom. So we want you all to be part of this house of wisdom, to contribute, to take what you learn, go back home and share that knowledge with others. We will now go for the first activity, which is going to be a lab tour. And it's going to be an overview lab tour to give you all an idea of the laboratory demos which will come later in the week. Many of our students, they're not here because they're there in the labs preparing everything for you, and they'll be joining us in the afternoon. Finally, I'd also like to welcome the people who are joining us on YouTube. There's about 35 participants watching live. We apologize they cannot be involved in the lab tour, but the online event will resume at 1 o'clock after lunch. So for those of you who are here with us, you're split up into groups A and B. When you go outside, let's have the group A assemble near the doors. We'll have group B assemble in the open area near the where the food was served, and then we'll split up and we'll go to the two different buildings. Group A will go directly to Building 7 with Professor Roberts, Professor Dibble, and Professor Lacoste, and Group B will come with myself, Professor Cha, and others to Building 5, and we'll arrange the lab tour accordingly. So please join us outside. Thank you.
But everybody will see both buildings.